Welcome to Endor. This is a gas giant about which we'll learn in Star Wars Episode 6 that has a small moon called the Moon of Endor, where the Empire was planning to construct a new Death Star. Now today we're going to do a little bit of discussion and science and a little bit of math on what happened to Ewoks. And hopefully by the end of this video you'll find out if Ewoks are still alive. Welcome to What the Math and enjoy the video. Now, to be honest, I got inspired to make this video because I've actually read a paper by a professor from Purdue University by the name of David Milton, who actually analyzed the idea of Ewok survival after the destruction of the Death Star. Now, this is a paper you can actually find in the description of this video. I posted the link for it. But let's start with the basics. This is the gas giant. We still have to construct the moon. So we're going to go into the moons here and create a randomly generated moon a little bit away from Endor. And this moon is going to be known as the Moon of Endor, for the lack of better names. Usually this moon and also this planet had the same name, according to Star Wars Wikipedia at least. And also the two stars that we have here, this is a binary star system, they're also known as Endor 1 and Endor 2. You see them in the background right there. So this is going to be our Moon of Endor. Doesn't exactly look like the tropical paradise that we see in the actual movie, but we can change that by maybe adding a little bit of water here. And before we change the composition, let's actually discuss another feature of this moon, and that's density. So Professor David Milton actually goes into detail about what he thinks the mass of this moon is, and he actually calculates it very precisely, or relatively precisely, to basically more massive than Mars and about 15% more massive than Earth. So we are going to actually change its mass, and actually I need to change it to this planet. We're going to change this mass to 1.15 masses of Earth. So you can see it starts growing right away because we just changed the mass of this moon. Now, but the other thing is that it's much smaller than Mars, and which means that it's actually very, very dense. Alright, so I've played around with the values a little bit, and so the mass is 1.15 masses of Earth. We also have a radius of 5,114 kilometers, but this is actually almost the double the size of the actual moon, according to Wikipedia. On Wikipedia it says that the size of this moon is, at least the radius of this moon is about 2,500 kilometers, so it's actually much, much smaller. Which suggests that this moon has a very, very high density, and even if I change everything to iron, which is the most dense material we have in this game, it still doesn't reach the required size, which suggests that it's very likely that the Moon of Endor is made up of some really, really dense materials, like, for example, uranium, or possibly, and that's actually what Professor Milton suggests as well, possibly uranium, and maybe even things like osmium, which is the most dense material we know today. So there's a very interesting composition, and this is something that I think someone should write a paper on as well. What composition would Moon of Endor have, which suggests that maybe Ewoks might be some sort of super creatures that don't even have iron in their blood. Maybe they have some other heavier materials that are even more dense than iron. Anyway, we're not going to talk about that yet. We're going to talk about something different. So, unfortunately, the current version of the game does not allow me to change the density without changing other parameters. So we're going to have to keep it at 12.3, even though it's a little bit lower than the calculated value of about 14.9, I think. That's what he calculates the density of Moon of Endor to be. So let's just maybe add a little bit of water so we have some lakes here and clouds and stuff. And as we add a little bit of water, you'll notice it will start acquiring oceans and rivers and transform into a more beautiful moon. So there you go. This is a little bit better than before. Now, okay, so that's ready. Now, what's the next part? So he also talks about the distance where the Death Star 2 is located, and using the size of Moon of Endor is able to calculate the size of the Death Star 2, and here the size is approximately 343 kilometers in diameter. So we're going to add another smaller moon orbiting around Moon of Endor. And it orbits at a distance of about 460-ish kilometers above the surface. So it's actually relatively close to the surface, so we're going to place it right here. Okay, and here we go. So Death Star 2 is in orbit now, relatively close to the Moon of Endor. Now, in his paper, he talks about how possibly the Death Star is actually in some sort of Endor a synchronous orbit basically right above the surface of one of the features on the land here. But the thing is, if it has any kind of a synchronous orbit, that means this would suggest that this particular moon has a very fast rotation speed of about 1 hour per rotation, which suggests that it would have 30-minute days, 30-minute nights, and it would most likely not even be so spherical. It would actually be more like a very flattened sort of a rugby ball. So the only other way for this to be in a synchronous orbit is if there is some sort of technology like anti-gravity technology that is basically holding this above the surface, which is quite possible. But nevertheless, we're not going to try to explain this. We're just going to basically make this more realistic in terms of mass and also size. Now, there's another paper by a few students from, I believe it's called Lehigh University, or I might have mispronounced this, that actually calculated the mass of the Death Star 2 to be about 10 to the power of 19 kilograms. So it's a little bit lighter than we have it here. So we're going to lower this to about 10 to 19, which also suggests that maybe it has a little bit less density, because obviously there's a lot of empty space on the inside. Alright, so that's done. So we have our Death Star 2 orbiting around moon of Endor, and everything looks fine until things go wrong for the Death Star. So as the Death Star 2 was constructed, obviously the rebels found out, they attacked it, this was a trap, but the rebels prevailed and were able to destroy it. And this is when things get really interesting. So even though we get to see the scenes of Ewoks celebrating the victory and everyone is really happy that the Death Star 2 is now destroyed, what this professor and a lot of actually other scientists, specifically here we're talking about 11 scientists from very prestigious universities, discuss is that because this is such a massive object and because it's so close to the surface of the moon, and also because when things get destroyed, you do create a lot of energy. First of all, it's very likely that some of the fragments that essentially get released in the initial explosion would fall onto the surface of the moon of Endor and heat up the atmosphere to the point where all of the water would most likely boil away from the surface. That's step number one. So the fragments that we're going to create when we destroy this are basically going to essentially evaporate the entire surface of Endor and very likely also burn down all of the forests. Now, we don't really know how much of the actual moon fell onto the surface, but we're going to, for a second, assume that if it's actually using this gravity technology to hold itself off the surface, and if you destroy the moon, which actually in the movie, if you watch the episode 6 again, you'll see that it's not destroyed in a very sort of dramatic way. As a matter of fact, it explodes relatively slowly. So when it finishes exploding, it's very likely that all of this chunk just sort of collapses onto the surface, which is what we're going to recreate here and see what happens if that actually occurs. And this is actually where some papers sort of differ on how they explain the explosion. So Professor Minton actually is a little bit more conservative with his values, but one of the papers talks about the speed of fragments as high as 200,000 kilometers per hour, which is actually very high, which would very likely possibly eliminate the entire moon of Endor. It would be completely devastated by this explosion. But what we're going to do is a little bit less dramatic. So we're going to go with Professor Minton's idea here and assume that as soon as the rebels essentially destroyed the core of the Death Star 2, the gravity generator stopped. So in other words, the actual Death Star 2 no longer held itself off the ground and then just slowly descended onto the surface from the altitude of about, I guess, 460 kilometers above the surface. And so we're going to just wait until this Death Star gets to the brighter surface of the moon and then stop its velocity and make it essentially smack down onto surface. So let's see what happens if this actually occurs. So this is essentially a recreation of the death of Death Star 2. And let's just go into here, and what we're going to do is we're going to go into actions right here and press the zero velocity button as soon as we're on the brighter sort of side of moon of Endor. And I think we also want to be a little bit in front of it because if I actually release the velocity right now, the moon of Endor is going to fly away from us, and because it's actually orbiting the two stars and also the gas giant Endor, it's going to basically escape from us. We want to do this right around here. I think this is a good spot, and here we go. Zero velocity. The reactor has been destroyed, and suddenly the Death Star has nothing holding it. It starts falling onto onto the surface of Moon of Endor, and we're just going to watch its total velocity. So according to Professor Minton, the total velocity at the time of impact should be around 2.8 kilometers per second. Let's see what we get here based on the calculations in the game. And so just watch the velocity graph right here, and right around, I'm going to pause this for a second just to slow down time, and right around the time of impact, the velocity is, it's already over 2 kilometers per second, so we might actually get very close to these predictions. And here we go, 2.4. This is already really fast. Imagine a very large 300 kilometer object moving toward you at 2 kilometers per second. And this is what, okay, so it was just under, I think it was just under 2.8, or maybe right around 2.8. So imagine you're standing on Endor celebrating, you know, the death of Death Star 2, and suddenly you see this. So if Ewoks had actually experienced this, this is what would happen. This is what would happen to their moon. And I don't think there would be much celebration. So first of all, look at the large shockwave that's sort of going around this this moon. And then just look at what happens to the actual surface of this object as well. So we have a bunch of fragments flying away. The explosion is tremendously large. The shockwave would most likely generate huge tsunamis, lots of earthquakes. And according to the calculations, the actual crater that would be left by this impact would be about 4 times bigger than the impact from the asteroid that killed the dinosaurs on our planet. So this would be about 700 kilometers in diameter, which is a huge crater when you think about it. And so the explosion here would essentially cause an extinction event on this moon. And in the fragments that are about to fall down here would actually obviously cause their own damage in various parts of the moon as well. But let's just keep watching what happens to this particular moon. We're going to accelerate this just a little bit. And let's see how much the temperature increases. So the original temperature here was about 30 degrees Celsius. And we're still not done with the impacts and everything else here. Surprisingly, the water did not evaporate, but I think that's because this particular simulation doesn't actually show us what happens when the atmosphere gets heated up. But based on the number of fragments that were flying around and just the size of the Death Star, it's very likely that the atmosphere would actually heat up so much that the entire ocean here would be boiled away. And all of the poor little Ewoks would be all boiled into little jerkies. And by the way, in one of the previous videos, I did talk about how apparently Ewoks were actually a game for certain races in Star Wars universe, and they were even hunted for their jerky. So people actually, not people, but various races used to come to this particular moon. And whoa, what just happened? Okay, I think I broke the game. I think I accidentally turned the zero velocity off for the Moon of Endor as well, and it crashed into the gas giant. That was not supposed to happen. That was totally not supposed to happen. But you know what? This is what happens if Moon of Endor crashes on Endor the gas giant. Alright, luckily I saved the game. Let's go back for a second. And this time we're going to try it again, but going at slightly higher velocity. So I'm going to change the velocity to something about 10 kilometers per second, which is actually one of the other predictions from the other scientists that talked about the actual Death Star explosion accelerating the particles and fragments to much higher speed. So we're going to change this to 9 kilometers per second, and it's going to accelerate by the time it gets to the moon. And here we go, explosion number 2 at a slightly faster speed, and look at that. Look at how much bigger this is. So what this suggests is that had the velocity been even bigger, and we actually just chose the smallest possible velocity, it literally just fell onto the surface. But if the velocity of fragments was higher, the actual explosion, the actual fragments colliding with the Moon of Endor would create a much, much larger impact, and would obviously cause a lot more destruction and a lot more collisions and a lot more destruction on the surface. And you can see that this is a much more powerful event, where basically the entire moon is essentially just completely bombarded by these fragments that are falling everywhere. And this is, of course, if the Death Star 2 has exploded so dramatically that it actually sort of created a huge amount of fragments that flew at really high velocities. And all right, so that's attempt number 2. And just for fun, let's do this again, but we're going to accelerate it even more. We're actually going to go with the highest velocity I could find. So one of the first scientists to publish a paper about the extinction of Ewoks. Oh, wow. I actually just warmed up my planet so much that it melted everything. It was, for some reason, it was frozen before, but the water has melted and the temperature is still increasing. So yeah, one of the other scientists actually predicted that maybe this speed would even be as high as 220,000 miles per hour, which is about 354,000 kilometers per hour, which essentially means moving at a speed of about 100 kilometers per second. So let's try this again, going at even higher velocity, 10 times higher velocity than we were moving at. So once again, we're going to go into actions, change this to 0 velocity. I'm going to have to slow down time here because this has to be very precise. And as the speeds start increasing, we're going to go to kilometers per second and change this to 100. So this is essentially if all of these fragments were moving so fast that they collided with the moon of Endor at a ridiculously high speed. And the total speed here is going to be just over 100 kilometers per second. And this is what essentially would happen. And observe the destruction that would occur on the moon of Endor had all of this been true and had Ewoks been real creatures living somewhere in a galaxy far, far away. And the first thing you'll notice is the much, much larger explosion that was created by this impact. And of course, the huge, huge shockwave that's about to go everywhere around the moon. You'll notice that the surface around the impact has already started changing. It's sort of more scorched, it's melted, and I have a feeling this planet might even melt completely. It might actually turn into a fireball. But look at the size of that shockwave. It's just going across the entire moon. So all of those Ewoks, except for maybe some on the other side of the planet, would be instantly eliminated, and the ones on the other side of the planet would very likely experience all of these fragments that are about to fall. There you go, there's one fragment right there. All of these fragments would basically finish them off. And if that wasn't enough, so the temperature change here would be so dramatic that all of the forest would basically die. All of the life as we know it on Endor would very likely disappear. And Ewoks, no matter how resilient they were, would very likely die of hunger, essentially. They would just starve to death. And so you're witnessing the face of Moon of Endor after such a large impact. So it didn't really change as dramatically as I guess I would hoped for, but nevertheless, even this size of a crater or this size of an impact would be so devastating that it would essentially cause a very massive extinction. And see how fragments are still coming back? So it's not over for poor Ewoks. They're still being bombarded by these extra fragments everywhere. And some of the fragments even went to the gas giant Endor, and they are bombarding it as well. So this would be quite an interesting view from the surface of Endor. If you just stand here and look into the sky, you see all of these Death Star fragments smacking onto the surface of the gas giant as well, and essentially causing a dramatic explosion everywhere. Look at this beauty. And I have a strange feeling that for some reason we're actually close into the gas giant once again, and we might actually smack into it. Because I think when I press the 0 velocity button, it actually for some reason slowed down the velocity of my Moon of Endor as well. So we're going to be crashing into it. Now, the actual collision would not actually change the orbit of Moon of Endor dramatically, but it would definitely shift it a little bit. So it wouldn't be even the same orbit around the gas giant. And here we go. This is going to be our second collision with the gas giant of Endor. And this is what it looks like from the surface of the planet. Oh no, we're falling onto the surface, and there we go. Dramatic explosions everywhere. Okay, so, and that's all I really wanted to talk about in this video, and hopefully you enjoyed it. I hope you learned a little bit more about how actual real professors and scientists around the world do take Star Wars seriously and actually use real-life mathematics to try to calculate if things that were mentioned in Star Wars were actually possible. And I think this is a pretty cool example of how many people do take science fiction seriously, because it inspired generations of people to become scientists, first of all, but also because sometimes it's actually important to differentiate between, you know, a drama that we get to see in Star Wars and actual science, which it might not be explained really well in some cases. Anyway, so that's all for this video. Thank you so much for watching. I hope you enjoyed it. I'll see you guys in the next video. Game you later. And as always, bye-bye. And if you still haven't subscribed, don't forget to subscribe because there's a lot more videos coming in the future. Don't forget to like this video if you actually liked it and share this with your friends who might enjoy Star Wars or like to watch different space videos as well. And if you're feeling super generous, don't forget there's also a Patreon page that would actually help me tremendously to make this channel even better and produce higher quality videos. Thank you and bye-bye.